In example 5c, our rational function is r of x is equal to 8x squared minus x plus 2 over 4x squared minus 1. We're interested in finding either a horizontal asymptote or an oblique. Okay, so again, it's all about comparing the degree of the numerator to the degree of the denominator. So when we look at this function, the highest power of x that you see in the numerator is 2, so this is degree 2. And then the bottom, the highest power of x is also 2. So both the top and bottom are both degree 2. So basically we have the situation where the numerator and the denominator have the same degree. Okay, so let's go back to our prior page and look at our rules. Okay, I'm going to start at the top with horizontal asymptotes. Okay, we're looking for the case where the degree of the numerator and the degree of the denominator are of the same degree. Okay, so that is going to be situation number 2, the one that's highlighted in green. Okay, here it is explained what happens if the degree of the numerator and denominator are of the same degree. Then it's going to be a horizontal asymptote. It's going to be located at y equals, you're going to make a fraction to get your number. It's the leading coefficient of the top divided by the leading coefficient of the denominator. Okay, so let's jump back over here. Okay, it's going to be y equals, because it's a horizontal asymptote, you're going to take the leading coefficient of the numerator, that's going to be 8. Remember, leading coefficient is the number in front of the highest power of x. So it's going to be 8 divided by the leading coefficient of the denominator. So the number in front of the highest power of x there is 4. So 8 divided by 4 is 2. Okay, so the answer here, this particular rational function, has a horizontal asymptote at, well, I shouldn't say at, I should say the equation of the horizontal asymptote is going to be y equals 2. Okay, so here's your answer. And remember, since we have a horizontal asymptote, we cannot have an oblique one as well. Okay, if you go to the next page, you can examine the graph of example 5c. It's right here. It's got 3 pieces to the graph, and then you can see a red dotted line that is horizontal, and it goes through y equals 2. Okay, so if you travel along both of these pieces at the top here, if I travel here and go this direction, we're getting closer and closer to that horizontal asymptote. If we travel on this piece, we're getting closer and closer to the horizontal asymptote from this piece as well. Okay, so y equals 2 is indeed our horizontal asymptote. Okay, all right, we have one more to do. Okay, that is function g in example D. Okay, so g of x is equal to 2x to the 5th minus x cubed plus 2, all divided by x cubed minus 1. Okay, again, there may be a vertical asymptote, but we're only interested in horizontal and vertical here. We need to compare the degree of the top to the degree of the bottom. Okay, so the highest power of x in the numerator is 5. So the numerator has degree 5. The bottom is degree 3. Okay, so what's going on here is that the degree of the numerator is bigger than the degree of the denominator. Okay, so let's go look at the rules. Okay, as far as horizontal asymptotes go, if we look at the purple statement, it says if the degree of the numerator is larger than the degree of the denominator, that's what we have here, then the graph will not have a horizontal asymptote. Okay, so we can already write down just from this observation there is no horizontal asymptote, but we still need to check on oblique. Okay, so if we go to the rules for oblique asymptotes, again, here is the situation in which you have an oblique asymptote. It's here in number 1. If the degree of the numerator is exactly 1 more than the degree of the denominator, that's when you're going to have an oblique asymptote. Okay, that is not what we have going on here. Okay, if you take the degree of the bottom and add 1, you're going to get 4. So if the numerator had been degree 4, then you would have had an oblique asymptote. But since, if you read in the second statement, if the degree of the numerator is 2 or more bigger than the degree of the bottom, then the graph's not going to have an oblique asymptote. Okay, so what's happening here, this particular graph has no horizontal asymptote. It also has no oblique asymptote. It is possible to have neither. Okay, so here is our answer for this particular function in terms of horizontal and oblique asymptotes. It has neither.